Hi everyone, this is Fahad Mirza and I welcome you to the channel. In this video, I am going to show you a very interesting and specific tool called as Query Translator Mini. It is a fine-tuned model of Qwen 2.57 billion which specializes in translating natural language queries into structured Orama search queries. Orama is a very interesting project which is a complete search engine and retrieval augmented generation pipeline in your browser, on your server or on any edge device on your network with full support for full text, vector and hybrid search in less than 2 kilobytes. I will be covering Orama in another video, but for now just remember that Orama is a search engine and you make searches with the queries. And this project or model, Query Translator Mini, converts your natural language queries into Orama queries. We will get this Query Translator Mini installed on our local system and we will see how it works. Also, I would like to introduce you to the sponsors of this video who are AgentBot. AgentBot lets you effortlessly deploy a personalized knowledge bot across platforms like Discord, Slack and others. It is ideal for open source tech communities and startups that provides user support, and I will drop the link to their website in video's description, so do check them out. Coming back to this Query Translator Mini, as I said, this is a specialized model. It uses PEFT, which is parameter efficient fine tuning with low rank adaptation to maintain efficiency while achieving high performance. It has been designed to convert these queries into structured JSON queries, and these JSON queries will be compatible with Orama search engine, and we will also see it hands-on. The cool thing about this Query Translator Mini is that it understands various data types and query operators, which really makes it versatile for different search queries. Now, those search queries operations could be greater than, less than, equal, and then you can even go with nested properties with dot notation, and it works with both full text search and filtered queries. Okay, so now let's get it installed and then we will see how it works. This is my terminal where I'm running Ubuntu 22.04 and this is my GPU card, NVIDIA RTX A6000 with 48 GB of VRAM, courtesy massed compute. If you're looking to rent a GPU on very affordable prices, I will drop the link to their website in video's description with a discount coupon of 50%. Okay, so let me first create a virtual environment with Conda. Should not take too long. And now let's install some of the prerequisites, which include torch and transformers. And now let me launch my Jupyter notebook. And we will play with the model in the browser. Okay, now let's download the model and the tokenizer. And the model is being downloaded, so let's wait. Okay, so the model is downloaded. Let me show you how you can generate the Orama search queries. Let me first paste the whole stuff here, which is from their Hugging Face model card, and I will drop the link to it in video's description. So you see, first up, we are defining the system prompt. And this is the thing with these specialized models, that you have to be extra careful when you're defining these prompts, because they have been fine-tuned on these specific prompts. So if you deviate from these, then the results might not be optimal. So for example, in this system prompt, it is being directed to the model that you are a tool used to generate synthetic data of Orama queries. Orama is a full text, vector and hybrid search engine. And then some examples are being given, like for example, the query is what are the red wines that cost less than $20. This is a JSON schema with key values, name, content, price, and then the generated query of Orama will be term where, and there's a specific format of Orama queries. So you see less than 20, something like that. Same goes for another example, and then last example. So 3 examples have been given, and then we are setting some rules like never use an embedding field, every query has term field, and these are very, very specific to Orama. Now, if you really think about it, you can fine tune any model for any other use case, and then you can use this system prompt in order to tailor the responses of the model. So I think this is why I really like this project, because this is so useful for any other use case too. Now we are giving it that another query what are the red fine that cost less than this. Then this is our Orama schema it has to stick to, and then this should be the prompt template we are defining. We are using tokenizer to encode the text into model understandable format, and then by using some of the hyperparameters to control the output, we are generating the output from the model, decoding it back with the tokenizer and printing it. So let me run it. And the model has come back with the response. So it has printed our example first, and then if you scroll down to the end, this is the Orama search query, which is perfect. Really good stuff. Okay, let's try out another one. So I'm just going to give it another query. So instead of this one, what I'm going to do, I'm just going to maybe go with another search query, and I'm just going to make it multi-line so that it will be easier to read. So I'm asking it, suggest compatible matches of women who share my interest in art, traveling and cooking, and are looking for a long-term partner. Let's see how it goes with this dating search query. Let me run it. While it runs, let's also check VRAM consumption. So it is consuming just over 15 gig of VRAM, which is same with the base model Quant 2.5 7 billion one. That is quite good, and it has already given us the answer. So let me go down. There you go. So this is a generated query. Looks good. This is a term, and then where clause with the equal one. Very nice. And then these are some of the explanation which it has given. Okay, next up I'm asking it slightly complex query that what are the most popular travel destinations in Indonesia except Bali with a budget of $2,000 per person for a 3-night trip. Maybe I'll make it harder. I'll just say 1,000 because everyone goes to Bali in Indonesia. So let's see if it is able to give us anything other than Bali. So let's wait for it to print the response. And also one thing you need to know about this is that there are few limitations of this, which I will shortly show you, tell you about. Let's first check out the response. There you go. Very nice. It has generated very fine answer. You see, this is the NEQ, not equal Bali, less than 1,000. Amazing stuff. So yeah, so it does not support array of numbers or booleans. That is one limitation. And then maximum input length should be 1024 tokens, not more than that. And embedding fields are not supported in the schema. Other than that, looks quite cool to me. So I will drop the link to it in video's description. Let me know what you think. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps. Thank you for watching.